Hey guys, so today we're going to go over numbers 7 through 14 in our section review. This is on page 266, our section review 8.1. So as you can see, I have 7 and 8 written right here. So number 7 says, what does mn above the arrow for in a formula equation mean? So if you look at page 265 in the textbook, they have table 2, all right, it says state symbols and reaction conditions. You can see that here. It might be a little small, but at the very bottom of that table, it says, it has an example. It has an arrow with a PD on top of it. A lot of people get thrown off for this one because they say, okay, that has PD on top of it, not MN. I'm looking for what MN means. But if you look at the meaning behind the PD over the arrow, it says name or chemical formula of a catalyst added to speed a reaction. So a catalyst is just something that we add to a reaction so that it will speed it up. It'll make it go quicker, it'll make it happen. Sometimes catalyst is required in order to make a reaction happen, let alone make it happen faster. So in this case, it's asking what does it mean if Mn is above the arrow? Same concept, right? So just means that manganese, in this case, because element Mn is manganese, is going to be used as a catalyst. All right, and if you want to elaborate and say that a catalyst is used to speed a reaction, go right ahead. All right. Number 8 says, what symbol is used in a chemical equation to indicate the phrase reacts with? Sorry, Sally barked. So if we are talking about two elements and I say that copper reacts with aluminum, okay? So we can think of that in terms of what symbol would we use in that case if we're going to write an equation. So without even reading anything, without thinking too hard, you can really start to see, well, if I'm going to put two things together, probably going to use a plus sign. All right. So in this case, you're going to answer for number 8 that the symbol we use to indicate that we are going to react with something else is a plus sign. All right. All right. So I have number 9 written down here. All right. So number 9 says solid silicon and solid magnesium chloride form when silicon tetrachloride gas reacts with magnesium metal. Write a word equation and an unbalanced formula equation. Include all of the appropriate notations. So as you can see here, I have our space for our word equation and space for our unbalanced formula equation. And up here I have a little note so that we don't forget to use our appropriate notations. All right, when they say appropriate notations, they just mean make sure that we're adding in those physical properties. Okay, so whatever state of matter we're in. So if we're solid, liquid, or gas, or aqueous. All right, and aqueous is something that if you did go through the section, you'll know aqueous is something between a liquid, well, it is a liquid, but it just means that it's mixed into water. Okay? And the symbol for that is AQ. So just like liquid is L, solid is S, gas is G, aqueous is AQ. All right? So here we go. We're going to write our word equation first. So we are going to follow along here with what they tell us. So word equation, we have solid silicon and solid magnesium chloride form when silicon tetrachloride gas reacts with magnesium metal. So that reacts with, they form when, okay? That means that those come after, right? So if I tell you that I made a loaf of bread from flour and a bunch of other good stuff, then just because I said the loaf of bread first doesn't mean that the loaf of bread came first. So this is kind of tricky and you really got to pay attention when you're reading these problems. We know that the silicon and magnesium chloride are going to be our products. So that means they're going to come at the end. So they form when silicon tetrachloride gas reacts with magnesium metal. So those are going to be our reactants. So we're going to write those first. When we're writing word equations, you don't need to write the state of matter. All right? So silicon tetrachloride, excuse my handwriting, this is not the best. I'll just take it down. Tetrachloride plus magnesium yields. All right, so we got our reactants done. All right, so we have silicon tetrachloride plus magnesium, all right, which we got from right here. Silicon tetrachloride gas reacts with magnesium metal, okay? Then I put my yield thing, I had to drop down. I don't have a lot of room here. Sorry if it looks a little wonky. Drop down, it's going to react to form solid silicon and solid magnesium chloride. So that means we can skip the solid, right? And we can just write silicon plus magnesium chloride. And I'll fill that in here. All right. So this, move over my books, is our answer for our word equation, right? We have silicon tetrachloride plus magnesium yields silicon plus magnesium chloride. All right. So now the next step is our unbalanced formula equation. All right. Hopefully we'll have a little bit more room when we're writing that one because we're not writing out all the words. So our unbalanced formula equation, we have to take this and write the formulas. So silicon tetrachloride. Think back to when we had our covalent bonding, right? The prefix tetra means 4. So that means we're going to have 1 silicon and 4 chlorines. So I'll write that here. And that's reacting with magnesium. Is magnesium one of our diatomic molecules? Let's check our list. So we should have this in our notes from when we did 1 through 6. I have it in my notes here. We have our 7 diatomic molecules here, and magnesium is not one of them. So we know that magnesium can be all by itself. Mg is the symbol for magnesium. Yields, let me fill you in before we move on. All right, so here's my unbalanced formula equation so far. We have the SiCl4 plus Mg, so that is the silicon tetrachloride plus magnesium. Yields, we put our arrows, same thing in our word equation as our unbalanced formula. And we write our reactants, or our products, I'm sorry. So silicon plus magnesium chloride, right? So silicon is Si, and it's not one of our diatomic molecules, so it's just Si. And then plus magnesium chloride is MgCl2, all right? And the reason there's no prefix on the chlorine there is because this is an ionic compound, not a covalent compound, so we don't have any of the prefixes. So here we are for the unbalanced formula equation. Now, what is that last thing that we need to remember? Don't forget our notations, okay? So that means we got to go back in and just put in our symbols for our states of matter. So SiCl4, we have silicon tetrachloride gas is what it says in our initial problem, so we know that we're going to put a G in parentheses after it. I'm just going to give myself a little bit more room. All right, so our silicon tetrachloride has a G after it for gas, which we pulled from up here, right? Silicon tetrachloride gas. Then we have magnesium, okay? So we have Mg. Does it tell us up here? Magnesium metal. So what state of matter is metal? Solid. All right, so we put our S in parentheses after the Mg, okay? And then we have silicon, all right, is our first product. Does it tell us? It says solid silicon, so what are we going to put? S in parentheses. And magnesium chloride, it tells us solid magnesium chloride in the problem. So put the S in parentheses after MgCl2 as well. So this is our final answer for number 9. All right, we have our word equation and our unbalanced formula equation. Now, number 10 asks us to do much of the same thing. So I'm going to take you through the steps, but I'm not going to do the problem for you because I want you guys to really try to work it out on your own. So we have, this one's a little bit easier too, so I believe in you. So we have, it's sliding, that's fine. So number 10 says magnesium oxide forms from magnesium metal and oxygen gas. All right, we're going to write the word equation and unbalanced formula equation. Don't forget your appropriate notations. So magnesium oxide, all right, think about what magnesium oxide is. Don't slip. So magnesium oxide forms from. So does that mean it's going to be a product or does that mean it's going to be a reactant? So if it forms from some other stuff, that's our product, which means that's going to go on our left side of our arrow, okay? So take a note here. This right here is your product. This is what you end up with, all right? Also, magnesium oxide is just one magnesium, one oxygen. So you're just going to have MgO for your formula there. It also says it forms from magnesium metal and oxygen gas, okay? So magnesium metal is going to be our first reactant, all right? The symbol for magnesium is Mg. And then metal means it's going to be a solid. And oxygen gas. Oxygen is one of our diatomic molecules, so you're going to write O2, okay? So your reactants, what we're starting with, are the Mg and the O2. Don't forget to write your state of matter, which is solid for magnesium, and G, gas for oxygen. Magnesium oxide is also a solid, okay? So I just want to tell you that because they don't really give you a hint here, but that's kind of like a salt, all right? So it's going to be your MgO, and then you're going to put S in parentheses after that, okay? So that would be for your unbalanced formula equation, and your word equation, you're just going to rearrange this and use your pluses and your arrows, okay? So that's number 10. Go ahead and try that on your own. You can pause this if you want to do it now. I'm going to move on to number 11. Got a little messed up. Let me just clean that up a little bit. Okay. So here we go. We have 11 and 12 on our board here. So 11 says, describe evidence that burning gasoline in an engine is a chemical reaction, okay? So some of you probably know way more about cars than I do. I'm not a pro when it comes to engines and all of that. But if you really think of it even from simple terms, right? When we see a car or bus or any automobile going down the street, you know that they put liquid gasoline in their car, but all we see coming out the back is a little bit of that exhaust, right? Which is what? Is it a solid, is it a liquid, or is it a gas? Sometimes there's a little bit dripping out, but that's not really the gasoline itself. What's coming out is the gaseous exhaust, right? A little bit of smoke, a little bit of whatever the gasoline byproducts are, okay? So describe evidence that burning gasoline is a chemical reaction. If you look at page 261 again, so on page 261, and I'll hold it up for you guys, hopefully you can see it. On page 261, they have table 1, the evidence of a chemical change, okay, right here. So if you can't see that, then I want you to just scroll through our online textbook. But it says evidence of a chemical change. If you're looking at that chart, then you'll be able to see the formation of new substances. If you look at that, that's really our go-to for anytime they ask us for evidence of a chemical change. So is there a formation of a gas? Yeah, we just talked about it, right? The exhaust coming out the back of the car is evidence for a chemical change. We could leave it there, or you could continue and talk about how there is a change in color, right? When you put the gasoline in, it's liquid, it's a little bit yellowy, and when it comes out, it's a clear or almost gray or brown, smoky stuff, right? So it's changing in color and a change in odor. So everyone can kind of smell that gas when you're at the gas station, and it's a gross smell. Exhaust doesn't smell good either, but it does smell different. So we have a change in odor as well. So those are 3 things that I would definitely say are evidence for a chemical reaction. Number 12 asks us a similar question, but it's asking about fireworks, okay? So describe evidence that chemical reactions take place during a fireworks display. Same thing here. I want you to go to page 261 and look at table 1. I'm not going to go over the answer for the fireworks one. I want you to just look at this list, and I'll hold it up again. Hopefully it is in focus, okay? So hopefully you can look at this list and figure out and identify things. You've all seen fireworks. Figure out different things from this list that prove to us that there is a chemical reaction happening. Again, not sure if that is picking up on the video or not, but if it's not, go ahead in your textbook, all right? It's on Google Classroom. All right, now we're on to number 13. 13 gives us a kind of elaborate question asking us about some epoxy glue that comes with 2 different tubes. I drew a little thing here for you because, I can't help myself. So we have 2 tubes with 2 separate liquids, and they want to know if these things are considered reactants. So neither of them are glue on their own. So it'd be like me trying to, glue 2 pieces of paper together. I put tube number 1 by itself, it's not holding them together. I put tube number 2 by itself, not holding anything together. You have to mix them together in order to form that glue. That to me says definitely reactants, right? So if they don't do the job you want it to do separately, but as soon as you mix them together, the product that you form is doing something completely different. So the glue that we get as a product of these 2 reactants mixing together, then that is a separate substance altogether, which means we have a chemical change, and those 2 things are our reactants. All right? Now, number 14, the last one we're going to do in this video, asks us, when sulfur is heated until it melts and then is allowed to cool, beautiful yellow crystals form. How can you prove that this change is physical? And I do encourage you to go on YouTube and look up, these things, these crystals being formed, all right? Sulfur smells really bad. It smells like rotten eggs, but it is a really beautiful yellow color. It looks so cool. So if you look that up on YouTube, it's just kind of fun. So they want to know, how can we prove that this change is physical? So think for a second. We just read that it's heated up. Then we read that it cooled down. And it went from liquid to solid. All right, maybe it changed color from the beginning to the end, but did we add anything else into this reaction? No, we didn't add anything to the sulfur to make it into anything else. All we did was heat it up, have it melt, and have it reform into a different crystal and make this yellow color. So this is a physical change because it's still silicon. Or it's still sulfur, sorry. So we started with sulfur, we ended with sulfur. We didn't change anything, all right, except for what it looks like. The same thing as throwing in your ice cube tray into the freezer, started out as liquid, ended up as ice, and that's it. It's just a physical change, it's still the same exact substance, all right? So in the next video, we're gonna go over 15 through 17. So go ahead and take your time finishing 7 through 14, and then when you're ready, go ahead and move on to the next video. See ya!